Good morning. Hope you all are doing well. So last time we started talking about the idea of static and as how that applies to variables and functions, meaning member variables and member functions in a class. So previously you've learned about, the keyword static, and we also saw that come up in the destructor example, where, one usage of static in C++ is to have a variable or an object that maintains its values in between function calls. But then we started talking about a very different usage of the keyword static towards the end last time. And it was this idea that we have an alternative compared to a regular member variable, right? Because with regular member variables, we know that they're stored individually for each object, which is what allows us to have different copies of that for each object, right? So for example, each time object can of course store its own hour, minute, and second. But sometimes we have data that we need to store that there only needs to be really one copy of it. And so that's where the keyword static can come into play in terms of member variables and member functions. So when we have a member variable in the class declared with the keyword static, then there's only going to be one copy of it, right? And all the objects are going to share that one copy. So in terms of memory, that also saves a lot on memory, since we only have one copy rather than storing it, individually for each object. And we also can have functions that are static as well. So we have variables that we can make static and functions that we can make static, but we want to think about the correspondence between those two things. And variables, right, we've been making private because of the rules of encapsulation that we really talked about at the beginning of chapter 3. And that still, right, is going to be the case with a static variable, right? We still want to think about, rules like encapsulation with things like a static variable. Because it's still, it's still part of the class. It's just we only have one copy of it instead of having separate copies of it for each object. So you still want to think about those rules, such as not allowing code outside the class to directly access it and change it and so forth. Which means that if we want to be able to access it in terms of the application program, then we're going to need, right, a function to help us do that. So that's where static member functions come into play. So the whole idea with a static member function is it's going to be working over working with your static variables. And so the example that we'll look at is going to be able to keep track of the number of objects in the class that have been created. And one of the things that we're going to be able to do is call a function that will return the number of objects that currently exist. And then we can do things like print that information out in the application program. Because really the code example that we'll look at is going to create some objects, and we'll see how the number of objects changes throughout various points in the program, right? So create some objects in nested scope level, and then, call the, in this case, it'd be a get type function really. Call the get function to return the number of objects, and then call it again when the objects have gone out of scope and been destroyed, right? So that way you can see how things are changing. So that's why we have static functions, right? They're designed really to work over static variables. And that doesn't mean that we only change a static variable inside a static function, because you have to think about, the more general case. And in the example that we look at, we said that we want to do things like keep track of the number of objects, but we have to think about what that really involves, right? Because keeping track would mean that at any point in time, when we call the get function, it needs to tell us exactly how many objects exist at that point in time. So what we're going to do is we're going to have our static variable, but we're going to have to be able to increment, right, and decrement its value. And so then the question becomes, well, where are we going to be doing things like that, right? And it's going to be in the, in constructors and destructor, because that corresponds to when objects are created or when objects are destroyed. So if we want to be able to correctly maintain this count of the total number of objects that exists, then every time we enter a constructor, right, we would need to increment the value of this static member variable. And of course, if we implemented multiple constructors, you would need to think about doing this in each of them, right? Because they all correspond to creating an object. And then we'll need to write out, our own destructor so we can put in a decrement type statement. So in the constructor and destructor, we'll do the, things like incrementing and decrementing. And of course, those are not static functions, right? Because we know that constructors and destructors can certainly change and initialize the regular member variables. So in that sense, right, we're going to have both non-static functions and static functions both working with our static variable. So both types of functions can work with a static variable. And then you can also think about, well, what about the regular member variables? Because we could certainly have a class that has both, right, regular member variables and static member variables. And can they be accessed in both types of functions, meaning non-static member functions and static member functions? And the answer to that one is no, right? So no, we cannot change a regular non-static member variable inside of a static member function. But we need to think about also why that is the case. Because it comes down to really the difference, what is really the fundamental difference between a non-static member function and a static member function? Well, a non-static member function, for one thing, has a hidden this pointer, which we talked about last week. We said that the hidden this pointer is how we always know inside the function which object it is that we're talking about, right? Which object that we're going to access or maybe change the values of the member variables for. And we said that you can refer to it explicitly with the keyword this. So in the time class, we can say things like this arrow hour equals whatever was passed into the parameter, like this arrow hour equals hour. And then that was going to change the hour member variable for the current object, meaning the object that we called the function with in the first place. And we recognize that when you call a non-static member function, that really the first thing that you're passing in is the address of the object, right? The memory address, which is being passed to the hidden this pointer. But what about a static function? Well, static functions really have one purpose: to work with a corresponding static member variable. And static variables are what we sometimes call global to the class, meaning there's only one copy, right, that's going to be shared across all objects. So it's only stored one time in memory. And so there is no current object then inside of a static member function, which also implies that there's no hidden this pointer either. And so for that reason, right, we also cannot access the regular member variables inside of the static member function, right? Because there is no this pointer, and so therefore, that's something that we can't do. But the point is that we should not be trying to do that in the first place, right? We should be able to do everything that we need to do with the regular member variable, right, and the non-static functions. The static functions are just for doing certain types of operations with the static variable, such as returning the value of the static variable so we can do things like print it out and display it in the application program. So in that sense, right, there's no hidden this pointer in a static member function, can access the regular member variables. And then also things like const, right? We've talked a lot about const and how when you're working with regular member functions, such as your get functions, right, they should always be made const, because that's a safeguard to ensure that the function cannot change the values of any of the member variables. And you can think about what that would mean in terms of a static member function. But the idea is that the keyword const does not apply to a static member function because it already doesn't have access to the regular member variables anyways, right? Because it also doesn't have a hidden this pointer. So we also cannot make a static member function const like we can a non-static regular member function, if you want to call it that. So no hidden this pointer, and then it's never going to be made const. But the one thing that it can do is access the any static member variables that you've declared. So those were some of the key points that we had hit on towards the end last time. And so we'll go ahead and look at the code example here. And what it's really going to focus on is this idea of keeping track of the number of objects. And with the help of what we're doing in the constructor and the destructor, so we'll create some objects at nested scope level. And we're purposely doing that so that way we can there's still more program when the objects go out of scope, right? And we can see how that value for the number of objects changes as things get created and then as objects get destroyed. And one of the things that we also mentioned last time, right, with this idea that static members are global to the class, is that when you think about things like calling, right, calling a static member function, what's that going to look like? And is that going to be any different than calling a non-static regular member function? And the answer is yes, it normally would look different. Because, when we call a regular non-static member function, we've been doing it in a few different ways, right? Using either the dot operator or the arrow operator, right? If we were working off of pointers, because we know that the dot operator is really the member selection operator, right? We're choosing which member we want to access for the object that's referred to on the left-hand side of the dot. But with the static function, right, we don't even need an object to call in the first place. Because remember, it doesn't belong to an object. There's just one entity or one copy. So there's a couple of different things you could do there, right? You can still access it with the object using things like the dot operator, but it's not really helpful to do that because there still is only one copy. So we can even access it even if we haven't created any objects yet. And what it comes down to is the familiar scope resolution operator, right? We know that we can always use that operator whenever we need to indicate what scope level something exists at. So when we want to call this static get type function without using an object, all we need to do in that case is refer to the scope resolution operator, because then the application program is going to know that we're trying to call that static function from the class as opposed to some global function that's not part of any class. So we'll see that in terms of the syntax of just calling it using the name of the class and that familiar scope resolution operator. So we'll pull up the code project here. Okay, so we'll look at this employee class example, and it's just going to show us the basic idea of how static variables and static functions are going to work here. So we have a constructor and a destructor. And so those are going to be important, especially here to write out, because that's going to be where we're doing things like the incrementing and decrementing of that static variable. We also have some other non-static variables here as well that we'll be able to refer to. So just a get first name and get last name, just regular type functions. And then down here, we have that static function that we were talking about that was going to be able to get the number of objects for us. And so in terms of syntax here, we just have the word static and then the return type and then the function and parameter list there. So takes and no parameters. And then here under private, we have the first name and last name as regular member variables. And then we have this count here, which is going to be the one that keeps track of the number of objects. And the idea is when you have a static member like this, if it's not constant, then we can't just, immediately initialize it right here. So we're going to be doing that we'll actually be doing that in the CPP file. If it's constant and static, then you can initialize it right there in the H under private. So we just showed that briefly here with count2, but we're not going to actually be using count2 in the application program, but just to show the basic idea there. But with count here, which of course is not going to be const because it's going to need to change, we'll set that one up in the CPP file. So we have the static member variable count, and then the corresponding static function get count that's going to return the number of objects. And then here in the employee CPP is where we actually initialized count to 0, right? Which is what we want it to be at the very beginning before any objects have been created. And so you'll notice the syntax here is we just use the scope resolution operator, right? So similar to how we always use the scope resolution operator with our member functions in the CPP, we can also use them with variables as well. So we just have the unsigned int, which was the type of the count static variable. And then we have the employee : in front of it. And then we initialize it in this case to the value 0. And the word static is also not repeated here either, right? So the word static was only used one time, right, in the H file, right there for the get count, and then here for the count member variable. So here we just refer to the type and then the scope resolution operator and then the variable name along with the value that we want to initialize it to. And then it's a similar thing for setting up the get count static function. So again, we don't repeat the word static a second time. We only do it once in the H file. So in this case, the return type was unsigned integer. And then we have the scope resolution operator as usual. And then get count, and then the body of the function is just return count, right? Return the value of that static member variable. And now first name was one of the variables, one of the non-static variables that we had. And we said that in general, a static function really has one purpose, which is to work over the static variables or to work with the static variables. So this would be an example of something that we're not allowed to do, right? Would be trying to access or change something like first name, which is one of the non-static member variables, or even a statement like that, which isn't even trying to change it, right, is still for the same reason not going to be allowed. So we don't have access to things like first name and last name here. Going back to the point earlier that we said that there's also no hidden this pointer either. So the only thing we can really do inside the static function is refer to the static variables, such as count or count2. So that's all we're able to do here is access those static members. So in this case, that's fine. The only thing we really want to do or need to do is return count. So in that sense, we're fine. And then we have, here's our constructor. We wrote out just one constructor in this case, which takes in two arguments for the two non-static parameters, meaning the first name and the last name. We just pass those as strings by constant reference. And then we're initializing those in the member initializer list as we often do, but then also look at what we're doing in the body of the constructor. Because in addition to initializing the first name and the last name, we're also directly working with that static member variable count with the statement plus count. So we are, right, certainly allowed to access static member variables in a non-static member function, including things like constructor. Because certainly that needs to be the case for this program to work, right? We need to be able to do things like increment count inside the constructor if we want to maintain an accurate count of the number of objects that currently exists. So it's very important that we are allowed in a general sense, right? Not just for this program, but a general sense that we're, able to access those static members in a non-static member function, because certainly that's something that can come up, such as here with the incrementing of count. So we do that, and then we also have just a short cout statement here so we can see when the objects are being constructed as well. And then likewise, we wrote out a destructor, right? So again, this was a time where we really did need to write out our own constructor and destructor because we have special logic, right? That would certainly not be happening with the default, right? Constructor, destructor would not be doing things like the plus count or minus count. So it's important that we make sure we have that in there. So our destructor here is just as a cout statement first to show when the object's being destroyed. And then we also have the minus to decrement it. So that way we still maintain the accurate count number, the number of objects. And then we have our usual, for the regular member variables, we have the get functions for get first name and get last name. So that's what the class side of the code looks like here. And now one thing you can also think about, because we talked about the different combinations in terms of, you know, what's possible versus what's not possible, or what's allowed versus what's not allowed. And we saw in particular that static members variables can be accessed in both static member functions and non-static member functions, which means also that, you know, you could potentially think about things like, for example, a get function that's not static that would, you know, return the value of that static variable. But that's not really ideal, right? When you think about how we might want to do things in the application program, because, you know, if you just make like get count non-static, and then you're trying to use that to return the count or the number of objects, but then we have to think about, well, how do we have to call a non-static function? We have to call it through an object. But a static member variable does not belong to an object, so that's not really a convenient way of handling this, because we should be able to call a function like get count even before we've created, right, the very first object. So that's why we have things like a static function, because that static function get count, right, we don't have to have an object to call it. So that's one of the things that we'll also see come up in the application program as well, is that it's certainly possible to call it without a static member function. Question about, by making get count unsigned, we are also making it static. Unsigned and static are two different things. Unsigned really just means that the value is going to be positive. And you talk more about those kind of things, and especially the 260 assembly class, about unsigned versus signed and why we might use one over the other in certain situations. But the idea here in part is that the count is always going to be a positive value, right? Either 0 or a value larger than 0. So we don't need to include negative numbers for things like the count. So unsigned just means that it's going to be a positive number, right? It's always going to be a positive number, including 0, but not including, right, the negative numbers. But we still need to say static also if we want it to be a static member variable rather than a non-static member variable, right? And same thing with the function as well. So anything that we want to make static, static in the sense of being global to the class, then we do have to use that word static, right? One time in the H file. So one time for the function and then one time for the member variable. But unsigned is, yes, is doing a different thing. In just the idea that it's only going to be positive. And since unsigned was used for the type here for the variable, we also use that as the corresponding return type for get count as well, just to make those two match up. Mm-hmm. Mm-hmm. Yeah, good question. So now the application program.